Hey, everybody, welcome to part 8. Before I go ahead and kick things off, as usual, for all previous parts, I'm going to give it just about 2 or 3 minutes for people to trickle in here. Welcome, 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 everybody. As always, please be sure to jump into the Discord for all of the Q&A, snippets of code that might drop in there as well, sharing files, stuff like that. So make sure you're in the SANS Workshop Discord channel. All right. So as more people drop in, we'll go ahead and kick off probably 2 minutes or 3 minutes past top of the hour here. For those that are in right now, if you've joined for previous parts of this series, for part 8, you will not need any files or any source code or anything from the previous parts of the series. This will be a clean break, if you will. Thanks, TBZ. Yeah. Glad you like the background. Maybe someday it'll be a real thing. Who knows? Cool. A few more have joined. Awesome. Welcome. Welcome to part 8. All right, about 1 more minute here, waiting for 3 minutes after. Yeah, someday soon, right? Soon is such a very strange word because when is soon, right? It's very subjective, I think. Soon could be next week, next month, next year. I don't know. Tomorrow. No way could I make a 5-day course with a CTF in 1 day. That would be intense. All right, sweet. 3 minutes passed. So let's go ahead and officially kick things off here. All right. So thank you everybody for jumping in live here for part 8 of the series. At a high level, here's what we're going to try to cover in this time block. I'm going to talk about threads, thread stacks, maybe jump into a debugger as well to look at them, maybe show you some extra tools that can help you look at threads, the various waiting states that threads can be in, stuff like that. And then also want to jump into talking about how you can dynamically allocate some memory. So like heap allocations, stuff like that, what to do with a heap, like default process heap, how to allocate a chunk to that and how to properly free it, that type of stuff, secure coding practices. And then if we can, towards the end, if you have any questions about any of the code that we covered today, please feel free to drop it in whenever you have a question into the workshop channel. And then, as always, towards the end of it, last like 5-10 minutes, I'll pause for any kind of questions you have related to this part of the series, previous parts of the series, or what's coming down in the future in the next couple of parts. I think I'm only going to do 10. All right, that's my goal here, 10. And I'll switch on to something else like WinDbg or C++. So cool. All right, so let's go ahead and get started, right? So if you're brand new, jumping in brand new to the series, welcome to the series. This is my a very, very quick attempt at trying to do an introduction to C on the Windows platform. All right, so we've done 8 parts of the series, or this is part 8 of the whole series so far. And for this particular piece, I have a solution here. I just call it intro, my intro solution. I've been doing this for each part of the series, and I just added part 8. All right. So again, You don't need any header files or really any source code from previous ones. We're going to have a clean break right here. All right. So what I want you to do right now while I'm jabbing away is I want you to add 2 source files. All right. So dirutils.c and a main.c. All right. Go ahead and add those to your project. All right. Those are source files. And also make sure you do .c, not a .cpp. All right. So I know Visual Studio, when you do a new item, a lot of times they'll default you to a .cpp extension. Just go ahead and get rid of those. Right. This is intro to C, not intro to C++. So cool. So once you have those, go ahead and add a header file. All right. So right click on that, add new item, and click on header file and name it dir utils. Because what we're going to be making today is basically like a dir walker. Okay, so a dir walker, learn how to enumerate a directory, look for files, look for subdirectories, parse attributes of them, stuff like that. Okay, so we're gonna tackle a good bit here. It's cool. All right, just to make sure everybody's on the same page before I move on. Cool. All right. Now, what I want you to do is inside of main.c, right? So main.c is where the main execution of your program is going to take place. One of the first things that I always do when I set up my main source code is to just bring in some includes. All right, looks like my VM is taking a good while this time. All right, so one of the things we always need to include is Windows. All right, so go ahead and tab it out, bring in windows.h. Then next thing we're going to need is standard IO. Okay, the only reason that we're bringing in standard IO is just for the printf. Okay, obviously, if you're ever creating an implant or whatever for Windows, you really won't need this because you're not going to be printing anything to standard out, right? Because there's going to be no active terminal. You're not going to be the person there watching those printf statements come out whatsoever. So this is just for like debugging purposes, if you will, so we can see the status of the program. After all, this is just an introduction. Okay, so cool. Now, one of the other things I like to do is a little custom define around cdecl. All right, so I'll define this little macro here, cdecl. All right, so that's our calling convention. Now I'll go ahead and get ready to make my main function. Okay, so that's what you typically will see for the signature, if you will, for main. But I like to be a little bit more thorough here and say cdecl. Okay, so this is the calling convention for C runtime functions. So I'm just going to be a little bit more explicit. And then inside of the parentheses here, because we are not going to have any arguments passing in here, I'm just going to say void. Okay. I may have made mention of this before, but in pure C, like a .c file, when you don't have anything inside the parentheses like this, right? So it's empty. You are not explicitly saying no functions will ever be passed to this, okay? Nor are you saying, yes, there definitely will be functions, right? You're kind of like, you're like lukewarm. You're not really sure, right? So we can definitely be sure and go ahead and say void. Okay, so it's a little bit different in C++. We'll talk about that in C++ in the series of how you really don't need void, right? So when it's empty, it's explicit. Cool. All right. So now we have our standard shell for our main function. And one of the things I like to do is start to initialize some local variables. So one of the ones that I always like to have is a type double word. And I'll just say last error. And I'll initialize this to error success. And eventually, it should come up as a list and you can tab it out. And I'll come down here a little bit more. and we will go ahead and return that. Okay, so set. All right, cool. We have our complete shell. If you want to, you can compile it in main.c and it should work just fine, but we're not done yet. All right, not done yet. Okay, so I made mention that we're going to be creating a directory listing kind of capability. Okay, so instead of having everything jammed into main, right? So we could have all the dir walking type of stuff baked right in here to main. That could be fine just to introduce you to, dir walking and some of the APIs behind the scenes. But I'm also a big fan of making sure that your functions are very small in size, especially main, right? Main is probably, in at least my opinion, is one of the functions that should really just kick it off by calling one or two other little functions that then call others. Okay, sometimes people call those wrapper functions that wrap around like a Windows API, something like that. Okay, so if you ever hear a wrapper function, that's what that is. Okay, so within main, we're going to kick things off and we're going to create a wrapper around a dir walk capability. Okay, so let's go ahead and save that. All right, saved. And then in the dir utils header file, here's what I'd like you to add in that. All right, so of course, what we need to add here is just some includes, right? Just to get it going. But before we go ahead and add in our includes, let's do a little pragma statement. If it's not in there automatically, you have to add this in manually. Typically, pragma once will already be there as you create a new header file. Okay, so cool. So pragma once, only include this header file once. Now we can go ahead and include Windows, and if we wanted to, standard IO. Sweet. Let's go ahead and create this signature for the dir walker. If I'm moving too fast, please let me know. Say slow down. Is it Visual Studio 2019 or 2022? Doesn't matter, right? Doesn't matter which one you're using. I'm actually using 2019 right now. If you're doing 2022, fine. It'll work just as good. So up to you, TPZ. Choose wisely. All right. It's cool. All right, so here's the signature for our little dir walker function. Okay, it's going to return to us a double word value. The calling convention, we'll just say win API. Okay, win API standard call. And then let's call it dir search. Okay. And right now, we'll just leave it empty. Okay, leave it empty and save it off. Okay, and then you'll notice a little green swiggly line may have shown up on your side of the house. Okay, all that means is you can hover over that and check it out. Basically saying we don't have an actual implementation yet for this function, right? I created a whole part of the series for creating functions that dives into this just a little bit more. One of the things that you could do is click on show potential fixes, and you got two options: create definition or copy signature. All right, so because you already have a dir utils.c file, you could go ahead and just say create definition. One thing that's really weird about Visual Studio is if you've already created like a main.c, and let's say for a minute, dir utils.c didn't exist. All right, so at that point in time, we'll say create definition of dir search in dir utils.cpp. It's not smart enough to recognize that you're creating a C program. And it's like, oh, I don't know what I'm doing here. I'm just going to go ahead and give you a CPP file and tentatively ruin things for you. All right, so I'm going to go ahead and say, go ahead and make that actual definition of dir search in your source code file. And it's kind of cool because it gives you a little like picture-in-picture kind of thing, a little pip of dir utils.c. And it gave us the return value, the calling convention, and says, go ahead and return 0. Okay. Cool. If you click inside of this little blue area, you can save that off. Say, cool, right? But I don't actually like programming in that sub window. Okay, so I'm going to come over to the source code file itself. And this uses me being picky. I like to change standard call to WinAPI just because no hard, fast reason. But I also like to bring things down on new lines. I think it's just a little bit more readable. And then possibly if you're dealing with like hundreds of functions, when you collapse, right? When you collapse it, I think it increases the readability as well when things are being collapsed. Okay, so that's just my personal preference, right? You can do whatever you like to do. Okay, so inside the dir search, what we need to do is call a few Windows functions to go ahead and say, let's go ahead and start enumerating a particular folder for any kind of files or subfolders or stuff like that, whatever might be there. Okay, so a little bit of background here real quick. I'm typing some stuff out. For NTFS, everything is actually a file. All right, believe it or not, even directories are going to be treated as files. And NTFS is a very transactional database, a transactional system where things have to be committed. So you have to commit a transaction to actually write an update or whatever to a file on disk for anything NTFS. Also, things can be rolled back. All right, so you can say, nope, I'm actually not going to go ahead and make this change. I'm too scared or whatever to hit save. So you hit the X and say, don't save my changes, right? So that stuff can be rolled back. All right, so it's a very transactional database. All right, so what I've done here inside dir search is similar to my main function. I just created a variable that's going to hold the last error, and I'm going to go ahead and return that last error. Okay, that matches my return type up here. So cool. So we now need to create some other local variables that will be specific for enumerating directories. Okay, so one of the things that we're going to have is something called a search handle. All right, so the search handle is of type handle. All right, so just start typing a handle, and you can say search handle, I suppose. And I will go ahead and initialize this to an invalid handle value and tab it out. Cool. I'm just going to make some comments as we go here. All right, so initialize local variables. And then this one keeps track of Win32 last errors. All right, so that one is the search handle. Okay, so a lot of times you don't have to be this fine-grained or this detailed with commenting your variables and stuff like that, like how they're going to be used or whatever. I would say if you're a dev in a more mature workshop or something like that, they might have some kind of standard that's a standard like in-house or internal to them to say, okay, every time you jump into a function, I need to have some kind of comment block that kind of dictates how that function is going to be used or describes how the function is going to be used. And then all of your local variables need to be declared and initialized right at the beginning of the function. And furthermore, every single variable that you have, you'll have to go ahead and add some comments about how each one's going to be used. What about the registry? What do you mean? TPZ, what do you mean by that? We're going to do like a red walker? Is that what you're asking? All right, see you type in there. Oh, still, yep, still even that. Yep, absolutely. And there's still files. All right. So in the code here, there's a specific structure that we need to use, and it's win32 find data A. Okay, so not to be confused with find data W. Okay, so we're just going to mess around with ASCII, ANSI standard. That way we don't have to deal with Unicode characters right now. All right, so win32 find data A, and I'll just say find data. And we want to initialize this to where every single member of the structure has the initial value of 0. All right, we'll go ahead and comment this out. This is our structure for the find, we'll say find wildcard APIs. All right, so you'll see find first file and find next file. So, okay, so initialize that structure. Okay, and then the next thing that I want to have you create will be three more variables that deal with the time. All right, so we'll have a last access time for a file. You'll have a write time, and you'll also have a create time. From a forensics point of view, you'll see the acronym MACB. All right, for modified access, create, and birth. All right, all tracking a file. All right, so we can go ahead and start to access those specific ones. We can hit everything in MACB except the B. We can't really pull out the birth. Okay, so just modified access create. So the structure type or the type of variable that we need to have is called system time. All right, so start typing in system time and you should see it show up in your IntelliSense. And let's do creation time. And set each one to 0. All right. And that's for the creation time of a file or directory or whatever. It's just an entry. Okay, so we'll do another one. Let's do this one for access time. Initialize everything there to 0 as well. All right, so cool. So that's the last access time of a file. And then one more, and this will be modified. All right, how's everybody doing so far? Is everybody with me? Hopefully everybody's doing pretty good. All right, like I said, if I'm going too fast, I'll probably go ahead and slow down. I got one DM say go a little bit slower. So sure, absolutely. Be more than happy to do that. All right. So cool. I got creation time, access time, and modified time. One of the things I want to create will be the absolute size or the full size for a file. That way, when we go through parsing every entry, we go ahead and pluck that out and give the full size. So a lot of times that can be a very large variable or large value. So we'll go ahead and say int 64. All right, so int 64, let's say full file size. All right, so int 64, full file size is 0. So this holds the int 64 value for the size of a file. And then just for extra gee whiz, when you do a printf, I believe this is going to need the format of, let's see, LLD. There's another one too. There's multiple. That's the first one that just came to my mind there. So this won't compile on a 32-bit machine then. We're going 64-bit. 64-bit. Who's got 32-bit Windows around the house anymore? I don't know about you, TBZ, but I don't have 32-bit things really much anymore. Besides that one Windows XP Service Pack 3 that I have just laying around. Other than that, everything else I got is 64-bit. All right. So we have that. Next thing is going to be that we can check out and play around with. It's called a large integer file size. And I'll explain a little bit of these differences between the full file size and the file size here in just a second. So this one is a structure. So we'll go ahead and initialize every member of that structure to 0. All right. And I think, let's see, this one I think is actually needed for some of the find APIs. So we'll say required for find APIs and the Win32 find data structure. Yeah. Okay, cool. Sweet. All right. So the next thing we have to add in here is the file name of where we want our enumeration to go ahead and begin. Okay. So we'll go ahead and just say this is going to be a char array. File name, and I'll say equals. Okay. So C:, whack, whack, splat. All right. So we'll go ahead and double escape the backslash and add in a little wildcard out there at the end. All right. That way you won't have to mess around with that later. Sweet. Stick with our formatting there. Okay. So that's just a folder to go ahead and start the search. Sweet. How's everybody doing? Yeah, you have an old XP machine as well? Cool. I assume silence is golden here, so hopefully everybody's good to this point. All right, let's go ahead and call our first function here to go ahead and give us a handle, our search handle for this particular folder, right? Whatever file name is going to be. Okay, so we'll go ahead and say H search handle or whatever you called it. And we're going to say find first file A. Find first file A. Because again, we're dealing with ASCII. We want to deal with ASCII strings or the ANSI standard here. And looking at this, if you just sit here for a second and look at the parameters that find first file needs, you can see we have to have a pointer to a file name. All right, so we can go ahead and take care of that file name. Cool. And then you hit the comma and it goes to the next parameter and it says, well, now we need a pointer to this Win32 find data A structure. All right, so what we have right now is just a variable that's on the stack, right? But we need a pointer to that. So we'll go ahead and say address of find data, right there, address of the find data variable of type Win32 find data A. Sweet. All right, so yeah, there's one of your first Win32 functions, I believe, being called so far in the series. Mine's, I think, part 6 and 7 had a couple others. Okay, so you'll notice that if other parts of the series, one of the things I'd like to do is error check right away. One of the reasons why I like to implement an error check right away is just in case something goes wrong with this function call for whatever reason. Who knows what could really trigger this and make this thing fail. But also because we're going to use this function called get last error, and get last error will only get the immediately last error that was set. Okay. So if you call 5 other Windows APIs after this one, they can all go ahead and set the last error. And if you're trying to error check this one, like 5 calls ago, that ship has sailed. Good luck. Okay. It's really not going to happen. All right. So we'll go ahead and error check. And I'll comment this one out as well. I'll comment on this one and say, grab the search handle. And we error check our call. And here's what I like to do for my little comparison. I'll go ahead and I'll take this invalid handle value. Just going to copy and paste it there. And I'll go ahead and do my double equal. Say, does it equal to the search handle? So if that pans out, let's go ahead and just return whatever get last error gives to us. Okay. In a debugger, this would be nice because you could go ahead and see whatever the last error is, whatever last error has been set by function calls. Right. I'll show you that here in a second. But also, if you're running this at a console, you can do echo error level or whatever, and you can go ahead and see what that what the last error message actually was. Other options you could do is you could go ahead and call printf to say, hey, our call to find first file has failed with this particular error message. All right. If you want to be more verbose with this. Okay. So cool. Here we are assuming that we're good to go, that everything is fine up to this point. And now we can go ahead and start to process the results and loop over all of the entries for this particular folder. Okay, so we go ahead and say, let's work with what you got. Work with what you got. So we're going to do this, no pun intended, we're going to do this inside of a do while loop. Okay, so instead of saying do while true, we need to go ahead and change the true. And we actually need to make another function call. So under here, say find next file A. Okay, and you can see the parameters that it needs. It needs your search handle, and it needs a pointer to your find file data. So H search and find data, but you'll notice it highlighted it red or underlined it red because I didn't satisfy the requirements of the function call and didn't give it a pointer to it. All right, so the and we'll go ahead and take care of that. Sweet. So we don't really need to do any kind of like error checking right here because find next file will go ahead and keep returning true while there is another entry to process. And by entry, I mean it could be a directory or it could be a file. Okay, so we'll get to that here in just a second. Inside of this do while loop, okay, so inside the body here, one of the first things that we could go ahead and take care of is go ahead and grab our file times. So let's go ahead and make some code to convert file times to system times. Sweet. All right. So the function that this is going to be is file time to system time. Super easy. File time to, you can see there's DOS date time, there's local file time, and then there's system time. That's what we want. And you'll notice that it's a type bool. So what's nice about that is we can go ahead and put this inside of an if statement to make error checking a little bit more, I would say, simple for us. All right, so I'm just go ahead and delete that one. and I'll create my if statement and the body down there. So we'll say file time to system time. All right, there we go. And we need a pointer to our file time. Okay, so where do we get that from? All right, now remember, this is going to be from the actual entry, the current entry that we're looking at right now. So that's going to be found inside the find data variable inside that structure. And we'll go ahead and just take a look at the creation time, right, for right now. Come on. All right, so FT creation times, right? File time, creation time. And then now we'll go ahead and give it a pointer to our system time variable for creation time. So just type in creation, tab complete. Cool. And then I don't know if you have the extra parentheses here, but I don't, because I see the red underline by my opening curly brace. So I need to close off that parenthesis. Not done yet with this if statement, right? I want this to go ahead and check for the failure of this function call, right? So what I want to do is kind of flip the inverse of this to say if not. So if not, file time to system time. So if for whatever reason this function call fails for who knows why, let's go ahead and just return the last error that was set by that function. Okay, so we'll go ahead and say return get last error. Cool. Right now, one of the things that we can do is we'll go ahead and take the two parts that is stored for this particular entry, and then we can go ahead and update our full file size. Okay, so moving on to file sizes. Oops. All right, so grab the full file size of the current entry. All right, so we'll say file size dot low part. So we got to grab both of these, right? So the high part and low part, doesn't matter which one. Guess we'll just do high because we're there, right? So we may make sure I'm not missing questions. Cool. All right, so file size high part. What do we put in here? Well, we go ahead and grab the high of the file size of the entry. So that's in find data. And if you just type in high, you'll see the N file size high show up, and you can tab complete that. So that's the high. Now we need to go ahead and pull the low. File size dot low part equals find data dot in file size low. Sweet. Not done yet. All right, because we actually haven't updated our full file size variable yet. So let's do that now. Full file size equals file size, the quad part. All right, so it's basically like the high and low put together, if you will. Sweet. And I'm just going to hit save. All right, so now one of the things that we have to do is figure out if the current entry is a directory or if it is a file. Okay, so how NTFS distinguishes the difference between a folder and a file is just by the attributes that have been set for it. There's tons of attributes, and we'll go ahead and we'll actually create and use a little macro to test all the flags of these attributes. But that is what we need to look for now. We need to go in and look for a very specific attribute to see if the current entry is a directory. So we can go ahead and add a little comment to say, are we dealing with a directory? So prepare your if statement. All right, so cool. So if, and here's what I do for the check. So I'm gonna go ahead and make another set of parentheses in here. All right, so inside this, I'll go ahead and say file attribute. Okay, so we're dealing with a lot of attributes for these files. So that's why it says file attribute. And you can see when you start typing this out, all the different attributes that are there or that can be applied to any particular entry, right? NTFS entry. All right, keep it generic. So we're gonna look for this attribute directory, and we're gonna do a bitwise and against the current entry that we're looking at right now. So that current entry is represented by find data. And we need to check this against the DW file attributes. So cool. That's a basic little check. Now, one of the things that could possibly, that we could possibly process with this code right now would be the little dot and the dot, right? We don't really care about seeing those. So what I want to do is check those away, if you will. All right, so I'm going to come in here and we're going to do a double and. All right, so and. We'll go ahead and make this little check to say 0 is not equal to. Okay, so then add another parentheses. And we're going to do a string compare, right? And case insensitive. Wow, what a day. Can't speak today. I'm very, very tired. The sun has warmed me out today. I think I've drank over a gallon of water so far. All right, so a little comparison here to see if we have a little dot, right, to represent the parent folder. So find data, file name. You may have seen the alternate file name in there. You don't want to be comparing against that one. All right, well, actually, we'll take a look at that structure here in a second. After this, we'll check, do the and. All right, we have one more check to check out. Another string compare for the dot. Okay, so that is a representation of the current directory that you're in right now. We don't care to see those. It makes no sense to go ahead and process the file name or anything like that. We don't care. So ignore it. All right, so one of the things I forgot to show you is this actual structure, the Win32 find data structure. And if you're wondering how in the world did I get here, well, I just went on to that structure variable type and hit F12. All right, so F12 opens up the header file and we see all the different fields that are inside of this. Attributes, creation time, see the MAC, right? File size, low and high. File name and alternate file name. Okay, so the file name, that's going to be the absolute path, right, for that entry. Alternate file name, if you haven't heard of it, it's called 8.3. 8.3 naming convention for NTFS. And 8.3 will literally have 8 characters reserved for the file name, the dot, and then a 3-letter extension. Okay, so one of the things you could do is, let me open up a command prompt. You can do this on your own too if you would like, or just watch my output here. I just jump into any folder, doesn't matter. And if you just do a dir listing, you can see everything being shown to you right now is the actual file names. So let me clear that. If you do a dir /x, you should see some file names that have like the tilde in it. That is the alternate file name being shown to you. Okay, there are a lot of shenanigans that you can do with the 8.3 naming convention. One of those shenanigans that I show in my class when I teach is how to load a DLL based on the alternate file name. Okay, you can also play around and delete the actual file name. So imagine if you were to delete something like this for the actual entry. If you delete that, what happens? Right. So some of the things I talk about in the class 670. All right, cool. You can go ahead and crush that. We don't need it anymore. All right, back to processing an actual directory here. Cool. So now we're dealing with a directory. One of the things that we could go ahead and display to the user, or for us right now, is just some basic things about it. So we'll do a little printf. And inside of this statement, what we'll go ahead and say is we'll go ahead and do like a placeholder that can be an indicator if we're messing with a directory or file. So we'll go ahead and say that's a %s. But for alignment purposes, how this can be displayed, we'll use a little bit of padding, if you will, for alignment. And let's do 14, I suppose. All right, so 14 spaces. All right, and then we'll go ahead and start to print out information about the time that particular directory, was created. Okay, so we don't have all the other creation. We don't have the other times done yet, access and modified. Okay, so remember, the only thing we've done so far is we converted creation time to the system time. You would have to make this call 2 more times to get modified and access. All right, just showing you create. So because we have create, we can go ahead and use it. And let's do a format like this. Let's do %d, %d, %d. All right, so look at like a month, date, year kind of thing. And I believe internally there are only two numbers or 2 characters. So if we do this, if we do %02, %02d. All right, so do that in your side too. All right, your printf, you got your string first, and then %02d to do a month, date, year, which is 2 characters, 2 numbers. Then the next thing we can go ahead and print out would be the actual time. So %2d again, and because we're doing a time, we do a colon right there. %02d again. And we'll go ahead and space things out a little bit. 4 spaces just to do a little bit. And this is where we can go ahead and jump in to pluck out the full size of the file that we're working with. So LLD, I think is what I mentioned before. Then the last thing we'll go ahead and print out will be the name of the file itself. Okay, and then I'm just gonna do a space in the new line. And if you do a negative or a tack right there, we'll go ahead and change how the alignment is going to be displayed on the terminal window. Okay, justify right, justify left, that kind of thing. So cool. Now the fun part, we have to add in every single argument for one of these format specifiers. Okay, so because there's going to be quite a few of these, one of the things I like to do is just bring some things down on a new line. The very first thing is a string. So we're dealing with directories right now. So we'll just say dir. Okay, so the next thing, we'll go ahead and use our create time variable to go ahead and grab month, or sorry, however you want to do it. You could do month, date, year, day, month, year, whatever. All right, so to show you a little bit of a different thing, let's do creation time dot, no, let's do day. Why not? All right, month. Last but not least, year. Cool. So I'm gonna go ahead and jump down a new line again. And now we're gonna do the time. Right. So the hour and minute. It's almost like it knew I wanted to do minute. Hour a minute. Wow, look at that. Just showing up exactly what I needed. Boom. And this is for the LLD, is the full file size. Sweet. And then the last piece is the actual name of the file itself. So C file name. Sweet. Should be good. Hopefully you don't see any little red squigglies or anything like that. Can I copy the format specifier to the Discord channel? Absolutely. There you go, TPZ. Good question. Good question. Saves a lot of time from you and jamming that all out, huh? Yeah. Cool. Yeah, no problem. No problem. Cool. So now we can go ahead and say, hey, you know what? If we're not messing around with a directory attribute, then we must be messing around with a file. Okay. So one of the things we can do just for commenting. Yep. So else if. And here we'll go ahead and just for clarity and just to be explicit, we'll go ahead and do the first attribute check that we did above, but we'll negate it. Okay. So we'll go ahead and say, and just copy this. Copy that whole thing, actually. Bring it down here. All right. Because we don't know if we're still going to be doing with a dot dot or a dot. All right. So we'll do the negation right there. All right. It's looking a little odd. Let me check on my parentheses. Mm-hmm. Okay. So I think it looks good. I guess we'll see in a minute. Cool. And if you wanted to, we can go ahead and just go and use the same format string that we used up above. So I'll go ahead and grab that. But let's go ahead and do 3 dashes. All right, so 3 dashes just to say we'll go ahead and parse an actual file entry instead of a directory entry. Cool. So that takes care of that. Now, if we wanted to, we can go ahead and start taking a look at all of the other attributes that a file could have. Okay, I'm not going to do them all. That's just craziness, right? We already used up an hour, so we got about an hour left. So I'll just do something real quick for you. I'll give you the macro, right, that we're about to create. All right. You may have seen this in other parts of the series. It's like a flag on kind of macro. And what's useful about this is, excuse me, you can do your bitwise testing pretty easily with this. All right, so let me bring that into Discord as well. Yep, got you there. All right, there you go, TBZ. There's the flag is on. So you can see what we're testing here. We're doing a bitwise and test for the actual value, and then for the specific attribute or the specific flag that we want to see if it's on or if it's set, rather, if it's set or clear. That's all we're looking for. All right, so flag is on. I don't know why I'm thinking flame on right now for Marvel. What's his face? What's that guy? Somebody help me out. Who's that character? Has to activate his firepower with flame on. Somebody will help me out. Drive me nuts. Nobody else a Marvel fan? Tough crowd. All right. So here we go. Inside of our if statement, we're going to check just one thing here. We're going to see if this is a normal entry. All right. So say flag is on and do the parentheses, kind of like you're going to call it. So we're going to say DW file attributes, file attribute. Looking for normal. There it is. All right. So is the flag set for file attribute normal? Okay. All right. Human Torch. Yes. Thank you. Yeah. Cool. All right. So if the flag is set that says this is a normal, this entry has the normal attribute tagged in it, let's go ahead and print that out. All right. So we'll say printf. How's this going to look? All right. It's going to come underneath this print statement. We got that to deal with. So it's what? It's roughly about a tab. Yeah, so we'll just go say tab. All right, tab in a space, and we'll just say normal. Cool. That's normal. So you could go through and do the same thing over and over and over again for every single file attribute that shows up in the list when you start typing file attribute. All right, so there's hidden, there's archive, compressed, wow, read only. There's a few others. Anyway, you can just go down the list that shows up. All right, for the IntelliSense. Okay, cool. All right. So I think at that point, that takes care of our dirwalk. Right. So that's a lot. That's a lot of code right there just for a little function. And all this is doing is very minimal, coming at the root of C and parsing everything that is a directory or anything that is a file. Okay. So what you could go ahead and do is get ready to go ahead and build this. Johnny Storm. Yes, absolutely. Awesome. Thank you for that, TBZ. Cool. All right. So now what we need to do is in main.c, we need to actually go ahead and call our particular function. All right. So remember also inside of main, it should be really short, right? Short and sweet kind of thing. Okay. So here we go. We'll go ahead and we'll use last error to go ahead and store any kind of last error that this dirwalk hits. And it's trying to type it out and be like, where is my dirwalk? Where's my dir search, right? It's not there. Okay, so here's why we didn't include anything. All right, include and then quotes dir utils. All right, so quotes just mean you're messing around with a custom include file, a custom header that you created. Anything that has like the carets less than, greater than should be a system header file that's going to look for in some of the known paths for all of the SDK or standard header files for Windows. Cool. All right, so we brought dir utils.h into our main.c. which gave us a flag on and which should give us dir search. One modification to make for dir search is annotation. If you do 3 forward slashes, it'll go ahead and auto-populate some documentation for you. You can say a summary, say something like enumerates a folder. Really can't spell today. Enumerates a folder. It's cool. Returns, let's say 0 upon success. Something like that. Okay, so that's good documentation to have. It's very readable. It can also be used to sort of like Doxygen. You can create docs for your API sets and stuff. But if you go over to the main and now you start to call dir search, you'll see that the IntelliSense will show you a little description of what the dir search is, says enumerates a folder, tells you what it returns and the file it comes from, which is really cool. All right, so we can get deeper into some of that stuff later on. All right, so dir search, no arguments yet. All right, so cool. Now, at this point in time, I want you to go ahead and try to compile your program. If you are keeping up with every single part of the series and you create one solution that has all of these projects, you'll want to make sure that your part 8 is set to the startup project. So if you just right click and choose set as startup project, boom, it'll highlight that and show it as bold. So that way, do a control B, we'll go ahead and build it, see what kind of errors show up. Oh, cool, nothing. Hey, all right. Now, if you were to do F5 to go ahead and run your program in a local Windows debugger, they'll do part 8. Okay, so it opens up another window and we got dir, we got a timestamp. Awesome. We got the hour as well. And military time. That's cool. And then we got the size of the file. All right, 0000. These are all for directories. Cool. Yep. Awesome. Sweet. So how did everybody do with that? All right, we're not done. Just want to see how everybody's doing. You copy paste everything after this line. What? So I know TPZ, that line you're talking about, I use that twice. Are you talking about the else if? First time. So you just want this? You want this whole thing? Is that what you're saying? Everything after it. Oh, you just want me to do all the coding for you. This is a workshop. This is a workshop. You're supposed to code with me, not I code for you. But hey, you know what? I'm in a good mood, so why not? I'll even give you my comment. Dealing with the file. All right, so it looks like Discord didn't take the tabification very well. So you'll have to deal with that. Was that what you were going there? Is that what you needed, TPZ? More. You're so picky, more or less. All right. Well, yeah, man. Yeah, you should let me know I was going too fast. Yeah, it's all good. It's all good. All right, cool. I got you. All right, hopefully that's all you needed there, right? Cool. Let's go ahead and press on then. All right, so we went ahead and built it and we ran it. Cool. All right, now let's go ahead and use a thread, right? So finally getting to the meat and potatoes of this, we just create a function to use for a thread, a very detailed function to use for a thread. Okay, so inside of main, what happens here is when main executes, it's going to be given its own thread to go ahead and execute the instructions, all the source code that we see here. You may have remembered that in previous parts of this series, I talk about processes and threads and stuff like that, and how processes don't run. They're just a virtual container for threads, right? Threads do the execution. A thread per Microsoft or per MSDN documentation says, paraphrasing, a thread is the smallest basic unit of execution. All right, so threads, they can be scheduled for execution. They're going to have a certain amount of time, like clock cycles, that they will be allowed to execute instructions. And then they'll go ahead and they'll be swapped out. They'll be swapped out for another thread, and its context will come in, and it will have some time to go ahead and execute its instructions, whatever it needs to do. So the time that it has on the processor executing all these instructions, the technical term for that is called a quantum. The quantum can be any number of clock cycles. I think for like servers, you get maybe like 12, like 10 or 12 cycles to go ahead and execute all your stuff. And I think for everything else, maybe like two or four. It's not very much. All right, so in any case, each thread is going to have a stack, right? A thread stack. Some of you may have heard the terminology that a thread's stack grows down, right, towards different memory addresses. Well, a thread stack can't grow at all, right? It's a fixed size. So that's a myth that we can bust and say all the blog posts that talk about stack-based buffer overflows and stuff like that, and say the stack is growing in a certain direction. It's not entirely accurate as far as technical jargon goes. Technical jargon goes. All right. So really, behind the scenes, the stack is a fixed size. Typically, the default size is 1 megabyte. Right? How that gets found is you start parsing the PE header. It has a very specific area that dictates to the system loader what the size of the stack should be for that thread. Right? So there's another place, though, that you can change the size of the stack, and that is by calling create thread. Right? So create thread, let me drop a link to y'all inside Discord. All right, so the first link is just one for MSDN documentation talking about processes and threads. Okay, so if you are kind of new to Windows processes and Windows threads, you can go ahead and start there. And then this link here is for how you can actually make a new thread. All right, so that's by calling create thread. There's multiple ways to make threads, but that's the only one we're going to focus on right now. All right, so create thread. Okay, and then we'll get into it here in a second, but I'll go ahead and drop the rest of the links that I have bookmarked. All right, so thread procedure, we'll talk about that here in a second. And waiting. And then talking about heaps. Cool. Now you have all the links, all my bookmarks. I can close those tabs. Give myself some memory back. Sweet. Cool. So now we know about a thread, what its purpose is, scheduling of threads, quantums, stuff like that, stack sizes. Let's go ahead and create a thread that executes our dir search function. Okay, let's get to it. One thing is we need to do inside main.c, we need to modify this just a little bit. So let's go ahead and we'll keep our dir search call, but we're not going to assign that to our DW last error variable. One of the things we need is a new variable that is of type handle, because this is going to be our handle to the thread that we call or that we create. So just go ahead and initialize that to null, or basically to nothing. Okay. And then down here, I'm just going to go ahead and comment that line out. So it's like Control Shift / I think, comments a line. All right. So now we can actually make the call to create thread. And we'll go ahead and assign that to our variable hThread. Let's create thread. All right. Needs a few parameters here. First thing is a pointer to security attributes. Okay, security attributes. What in the world are those? So taking a tangent a little bit about Windows internals, more Windows internals. Every single object that gets created by one of these create functions, that object actually gets stored in the kernel, in the Windows kernel, system space, if you will. Okay, and it needs to be protected. It needs to be protected in such a way that any average Joe process can't just willy-nilly come in and modify a particular object however they want. So there are security attributes that can be applied to these objects that get created to say, hey, you know what? I don't want anybody to like inherit my handles or stuff like that. You don't want to have too many handles open to a particular object. Maybe there's only one handle that's allowed to an object. Various types of ways that you can lock down access to these objects. Okay, so in any case, first thing we need here is that pointer to the security attributes, but we're not going to really give it one. All right, we're going to give you a null pointer because I don't care. I don't really care. I want you to go ahead and assign the default security permissions or the security attributes that that the current process has, or like a parent process has. All right, cool, fine. Next thing you'll see is stack size. This is where you could go ahead and say, I actually know the size of the stack that I'll need for this thread and what it's about to do. So you can make it a small stack size or whatever, or you can say 0. All right. And you're like, wow, that's a really small stack size. No. All right. We're not saying it's going to be a stack size of 0. That's going to say, hey, I don't care what it is. You figure out what it should be. You just go ahead and give me the default stack size, which is 1 meg. Cool. So the next parameter is our start address. The start address is basically saying, hey, point me to the code to where I need to start executing. All right. So a lot of times that can be shell code for people trying to do like shell code injection or stuff like that, or DLL injection, anything like that. But what we're going to do, we're going to use a thread in a legit manner for now, and go ahead and say, let's go ahead and kick off our dir search. And you'll notice the type that it needs is a pointer to the thread start routine. Well, that doesn't match the signature that we made for dir search, not at all. In fact, if you go to that link that I gave you for thread process procedures for callbacks, you'll see the actual signature that it needs. Right. So because we're not going to mess around and change our signature, we're going to go ahead and do a typecast. All right. So we'll say LP thread start routine. There it is. And we'll say dir search. Okay. So you don't have to do the parentheses after this, okay, because they're not calling it. Right. We're just saying, hey, this is the address of dir search. That's what that is. Right here, right now, without parentheses, this is like the address of where dir search is going to be located when it gets mapped into memory. So cool. Oh, no. Oh, get out of here. There we go. All right. The next parameter here is of type LP void, right? Pointer to nothing, right? Pointer to void. This is actually reserved for an argument that you can give to the function. Okay. We're not gonna mess with this yet. We'll kick off the thread and then I'll show you how to pass an argument to a thread. All right. So because we're not going to give it anything, we'll say null. All right. Null in all uppercase. Creation flags. All right. We don't really care about this. So we can just say 0. And then thread ID. This will be the kind of like a process ID. This will be the ID for this thread that it's been given. We don't care. If you want to optionally store this in a variable, you can. And you could do like a printf to say, hey, thread ID, whatever, has been created. Sweet. But it's actually an optional parameter. And I'm going to exercise the option to not give it a pointer to a local variable for that. Sweet. So here we go. This is the basic way, the most basic way to create a thread that does the thing. The thing that this is going to do is go ahead and implement our dir search. And one of the things we didn't do yet is actually do a quick error check for our function call. So let's go ahead and do that now. And let me get up with my comments. Cool. So just make a thread to do dir search and error check. All right. So if we don't have a legit handle to our thread, then we'll come in here and say, let's go ahead and just return get last error to kind of figure out why. Why in the world did this call to create thread fail in the first place? Okay. All right. Let's see. What if I have a function that has a parameter that needs to be called with it? I think I kind of mentioned that there, TBZ. This first call here, I'll show you how to do it in the most basic sense. And then later, I'll show you how to pass an argument. All right, so stick with me. I'll get you there. All right, I'll show you my way. A good question. Cool. All right, so there it is. We did a very simple error check to say, hey, cool, did our thread actually create? If not, return get last error. Okay, sweet. Go ahead and save it and build it. See what happens. Awesome. And run it under local Windows debugger and get nothing. What? What in the world? Why didn't I get any kind of information? Because before we turn this into a thread, we know it works. We saw all the entries under C, right? We saw files, we saw subfolders, subdirectories, stuff like that. What in the world happened? All right, let's check this out. Let's implement a breakpoint. Right. I guess it really doesn't matter where too much. Write the function call find first file A. Okay, so I'm building this in debug mode. All right, so this will be good. We'll hit F5. Cool. All right, just letting everything come up here in the debugger view. Okay. Right now, if you look at Visual Studio, you may or may not have this little window open. It's called Parallel Stacks. If you don't have Parallel Stacks, go to Debug and go to Windows, somewhere around here. Should be Parallel Stacks. There it is, Parallel Stacks. This is a nice way. Let me zoom in a little bit more. This is a really nice way to look at threads and their stacks. Okay, so we see we have main thread. Okay, so main thread, looking at the call stack here, we have going down to the very bottom. You can just hover over it. Main CRT startup, main C runtime startup. That is actually what's going to call our main. Okay, you can see there's a few more function calls here, but then look at this. Exit process, RTL exit user process. Interesting. but we're in a breakpoint. We're in a breakpoint in this thread right here. You can see how it's highlighted and bordered blue because we're in a new thread that's executing dir search, right? So there's no like call stack for it or anything like that. You can look at, you can see like there's a little stack frame there. Okay, cool. But under the main thread, we can see this thing is about to exit. It's about to terminate. What? Well, maybe we can go ahead and step through this, right? We're in a debug state. Maybe we can go ahead and just step over this. Let's see. All right, so step over F10. Nope. Nope, not one bit. Can't even do that. It's already exited with code 0. All right, so it put it in a thread, not an original process. What do you mean by that, TBZ? Can you expand? It put it in the thread, not in the original process. Because we created this thread from the original process. All right, while you're typing, I'm going to go ahead and talk about this. No, we absolutely did. Absolutely, we did. Okay, so right here, right? So main gets its own thread. Cool. So that thread kicks off another thread to do the thing. Sweet. We hit that breakpoint and all that jazz. So cool, but the thread didn't actually do the thing. Here's why. We weren't actually waiting for that thread to do its thing, right? We just said, cool, return last error. We got nothing else to do. We're done. So exit. Let's go ahead and exit. But what we really should be doing is waiting. We should be waiting for this thread to go ahead and complete. Okay, so we'll go ahead and implement a wait. And if you look in the Discord channel for the SANS workshop, I gave that link for wait objects and talk about waiting on things. Okay, so here, right after our error check, we'll go ahead and call wait for single object. All right, so wait for what? What are we waiting for? What object are we waiting on? How long do we wait? Okay, so what we'll give it is our handle to the thread. And now we can say in milliseconds, how long you want to wait. All right, so how patient are you? So let's go ahead and let's say we are forever patient and do infinite. Cool. We will wait around forever. If you hover over infinite, you see it's all F's, pages -1. Wait around forever. So no matter what that thread is doing, if it hangs or some bad code is executing there, doesn't matter. We're going to wait and block. So the thread that executes main is going to be in a blocking state and wait until this new thread is done doing its thing, which is dir search. Okay, so if you've made that change, you added in the wait for single object, go ahead and save it, build it, and run it. Okay, cool. There it is. Look at that. Sweet. Now we actually can see all the outputs from that thread because we waited on it. We're like, hey, I'm going to wait for you to do your thing. We're not going to go ahead and exit the process prematurely and crush everything that may have been going on. Right? So cool. Now we see our dir listing of C:. Okay, awesome. Now I want you to play around with this. Check this out. I want you to go ahead and comment this out. Comment wait for single object. Save that. Go to your dir search. And here, just to prove a point, never do this in production code. Let's do while true. All right, so basically forever. Let's go ahead and print out something. So printf, what do we print? Let's just do this. Running in thread ID. What's that return? Too long? Probably. I guess we'll find out. Writing in thread ID something. So now we need to get the thread ID. So get current thread ID. Okay, so we'll call that. Let me hover over that one. Oh yeah, double word. All right, cool. So cool, LD. Sweet. Save it and go ahead, run it. Huh. Look at that. Look at that. That's craziness right there, right? Now I'm going to do it again. See if I can get any a single print statement. Nah, ain't happening. Okay. So coming back to the main, we'll go ahead and give that back and execute that. There it is. That's the thread that we're running in. That's the thread that we were waiting for all this time. And because we're waiting forever, that thread is going to be forever printing this out. Okay. So one of the things that you could have done optionally is if you ever have a thread that gets into like a hung state or just bad code or something like a forever loop, inside your wait for single object, you can change the milliseconds to be something that's not infinite. And maybe you're not very patient. Say, I'm only going to give you 20 seconds to do your thing. And if you're not done by then, we're finished. I'm going to terminate you. All right. So we'll go ahead and terminate now. Cool. I don't care about the exception. I know that was a control C exception, yada, yada, yada. Don't care. Sweet. Okay. All right. So now that we have this done properly, we're waiting on this thread object to be done. We're waiting forever. Go ahead and into your dirty tills, put that breakpoint back on find first file. Once a breakpoint is back, go ahead and hit F5. Oh, garbage. And make sure you get rid of the while loop. All right. So once the while loop, while true is gone, go ahead and run that again. Cool. We're good. All right. Let everything come up. Let's look at the parallel stacks. I'll move this a little bit. Check that out. All right. So the stack for a main thread is looking fine. All right. We don't see anything that mentions exit process or anything like that. So what that indicates to me right now, just by looking at the stack here, we should be able to go ahead and just step through the code inside dir search inside a different thread. Right. So just to get you more familiar with this parallel stacks. Okay. So you had a thread that kicked off main. Okay. And then main kicked off a thread for dir search. And that's what we're doing right now. Okay. So let's hit F10. Cool. Sweet. We're stepping through code. Awesome. Perfect. Sweet. Now, if you wanted to, you should. Come on now. Yeah, source not available. If you wanted to, you can go ahead and click on any one of these stack frames and check them out. Okay, so looking at invoke main, looking at the the C runtime for common main SEH. Okay, and it says, excuse me, you can actually see the source code here for the C runtime, how everything kicks off. Look, on my side, it's line 288, and it says invoke main. Cool, right? So if you were ever curious how the C runtime really kicks everything off, check out the source code. The source code is there locally on your dev box or wherever you have the SDK installed. Okay, so looking at invoke main, cool, awesome. Excuse me. So you can go all the way to the bottom to see how in the world this thing started. All right, so return SCRT common main. And let's go back to this one. So double click over there. All right, so easy to move around to different stacks and different stack frames for various threads. Okay, that's kind of cool. Very nice feature that WinDbg has. Where was parallel stacks again? All right, so once you have a debugging instance open, go ahead and do debug, Windows, parallel stacks. Ah, good. Glad you found it. Cool. All right, go ahead and continue. Done. Good to go. Sweet. Awesome. We got our thread. All right. And now we also talked about thread stacks, how to look at different thread stacks, stack frames, stuff like that. The one thing it didn't mention, what is a stack frame? Okay. So a stack frame will belong to a function that gets called like dir search. So dir search will have a stack frame of a certain size to hold things like local variables. Local variables specific to dir search will be there inside of its stack frame. Any arguments that get passed to it could be applicable as well. But that's as in a high level overview, that's what a stack frame is. And those get torn down when a function returns. Okay. So now let's go ahead and talk about how in the world you can pass arguments to functions that get called via create thread. All right. So here you go, TPZ. This one's for you. Okay. And we'll also go ahead and talk about dynamically allocating some stuff on the process heap. Okay. Don't need that. Don't need that either. Let's go back to main. Sweet. I'll comment that one out. All right. Because now we're actually going to go ahead and call this with a parameter for it. Okay. One of the ways that I like to pass an argument or arguments to a thread is by way of a structure. And so one of the structures that we can make here, just for a very, very simple example, something like this. So inside your header file for dir utils, go ahead and type this out. Type def struct. We'll just call it args. Why not? And then we'll say args without the underscore, and then a pointer to args. And I just like to have things on a new line. Okay, cool. So the structure member that this will have will be, let's just give it a, let's just do file name. All right, a file name array, char array. So file name, and then semicolon. And inside of this, we'll just say max path. You know, why not? You can do that. You can leave it blank too. All right. Some people like to do one. There's something I think any size array. Any size array is just one. A lot of times you'll see Windows do this internally when they're dealing with some structures where they don't know the amount of data that's going to be put into it, right? You don't know the size. I've used this kind of trick or kind of thing for my C2 projects for like implant communication between the implant and the C2 side, the controller. That way you can stir copy into it, you can mem copy into it or whatever. It's a very nice little trick. But in any case, let's go back to max path. Max path 260. Fill it up. Don't need to do an max path, but let's just keep it. Okay, so args now, well, that will be available for us inside of our main.c. So let's go ahead and get some args ready. Okay, so now let's go ahead and allocate something on the heap here. Okay, so I'll go ahead and create a local variable. Oop. Come down one more new line just so you can see this a little bit more clearly. This is going to be a pointer to our args structure. So pargs. And let's go ahead and call heap alloc. Okay, so heap alloc. And the first parameter we see here is a handle to the heap. Okay, what I like to do just to keep things simple is I'll go ahead and grab a handle to my process heap. So get process heap, right? And don't pass anything to it. Hit the comma and flags. So if you check out the link I gave you in Discord, you can see some of the various flags that you can set and that you can pass here. But we're going to say heap 0 memory, because this chunk of memory that I want it to make for me, I want to make sure it's all zeroed out. So I'm just going to explicitly say 0 your memory. Next piece is how many bytes do you need? Right? So how big of a chunk do you need? One of the things that I like to do is I'll just say, you know what? I need the size of my args structure. Okay, that's what I need. That's how many bytes I need. You could try to hover over it and it says 260. Awesome. That is the size of our structure. Now, don't do this. Don't do P. Don't do P args. All right, size of P args. Okay, that is not the same thing as size of args. So let me go and leave that back in here. And if you hover over that one, that's a pointer, right? Size of a pointer for 64-bit programs on 64-bit OS is 8 bytes. That's not going to do any good for us and what we want to do here. So we get rid of that, and it's just args. Cool. Now we go ahead and we need to do an error check. Let me get caught up with my comment here. Okay, so allocating a chunk in the process heap with error checking. And so if, get that ready. So if not pargs, all right, so if we don't have a pointer to this chunk of memory, then we'll just go ahead and return get last error. There you go. Yeah, get last error. Sweet. Hey, so we should have something good in the heap at this point in time. Now, the next thing we have to do is we have to actually fill out that structure member for file name and give it something. You got to put something there. So let's take care of that. Now, there's a few ways that you can approach this. A few functions that you can call to do this. There's RTL move memories, RTL copy memory, there's mem copy, stuff like that. So what I'm going to do is mem copy. I'm going to show you something. All right. So the destination is our file name. The source. Let's just, why not? YOLO. Let's just do it all in here. C users. Let's do that. And then the size. So stir length. And I'll copy this. Definitely not the best way to do this, but we only have about 20 minutes left to get through some things I want to get through. All right, so all we're trying to do here is mem copy this value right here into our file name array that we allocated on the heap. Sometimes you'll see people do something like this after stir length. They'll do a +1. If you know why somebody does that, please go ahead and add that into the Discord. All right, just curious. If anybody has a hunch as to why some people do that. Okay, I'll give you just a second. All right, cool. So here's why. So stir length, strlen will not take into account a null terminator. So when a string is created, right, a lot of times it'll have a null byte at the very end to say, hey, don't look any further than this byte because this is the end of the string. You could totally just keep this here. That's fine. We'll say, go ahead and grab me the length of the string plus the null byte and shove that over to file name. Well, here's why you can get away with not doing that. this right here. We said in our chunk, I want to make sure that you have zeroized everything there. All right. So a bunch of zeros allocated on the heap. And then you don't really have to worry about doing a +1 after stir length to go ahead and grab that null terminating character. Okay. All right. But if you wanted to add it in there just to give you that warm and fuzzy feeling that you're taking that into account, feel free. All right. But that's very specific to this right here. Right. Just because I know the memory it's going into has nothing but zeros. And so naturally it's going to have a 0 after the string. Cool. All right. So that's memcopy, but let me talk about something else that's really cool. That'll be intrinsic functions. All right. Intrinsic functions are functions that are internal to the compiler. So AMD, or the processor AMD, Intel, right? So two very, very popular processors can support intrinsic functions. Also, processors, and then various compilers, MSVC, Clang, GCC, so on and so forth. They will also have functions that they know internally as well. Okay. What the benefit is for using an intrinsic function is there's no actual call to those functions. They're forced inline and the save some speed and efficiency, increase your speed and efficiency, but they're also really good for shellcode. All right, so here's how we mess around with intrinsic functions. If we do pragma, all right, so a pragma directive, say intrinsic mem copy. I'm going to include the intrin header. Okay, so cool. So what I'm trying to tell MSVC here, the Windows compiler, is I'm saying, hey, this mem copy down here, don't generate a stack frame for it. Don't actually call it. I want you to make everything in line. And it can really help out in a number of ways. All right, so we're going to get rid of that little function call. Okay, so compile that. Build it, save and build, see what happens. Cool. All right, everything is good so far, right? Built it, no errors. Now let's go ahead and actually pass it. So I'm going to copy that line down one more, but instead of saying nothing here, let's say pargs. All right, so that's our pointer to our structure that we have on the heap. So cool. All right, now we have to go and make a modification to our dir search function, because right now dir search, it's not expecting any kind of argument right now. Let's modify that. So here, let's see. Okay, so if you look at the MSDN documentation for a thread procedure callback, you'll see this sal annotation being used for in. What that's saying is the parameters coming through here should be treated as read only. We shouldn't be doing any kind of modifications for it. Okay, so let's go ahead and modify the source code. Okay, so we see it's been highlighted or underlined green. We can't have that. We got to fix that. So I'm just going to copy that and go to my source code file. Come up here inside the parentheses. We'll say LP void and LP param. And you don't have to add in the sal annotation like this, right? We can go ahead and get rid of that and use a different annotation. All right, so use decal annotations. Okay, I'll go ahead and save that. Okay, cool. before that, you may have seen this little highlight. It says inconsistent annotation for dir search. The instance has no annotations. What that is basically trying to tell you is inside your header file, you have this annotation right here to kind of tell you how the parameter is going to be used when the function is called, right? It really helps out with readability. So we'll say use decal annotations to say, go ahead and go to the header file. Whatever style annotations are there for all of my function parameters, apply those. That way I don't have to type them out over and over and over again, right? I have a section specific for style annotations in my course. We dive deep into these and I show you some really complicated annotations that you might come across. Cool. So now inside dir search, we have this parameter coming in. We should do a little check to make sure that we actually have something coming in. So if LP param, so cool, we got something. Let's print out what we got. All right, because we know we're passing a string to it. Okay, so let's see. Let's call this thread arg. It's a string. They might be wondering, how in the world am I going to get this string? How do we do this? LP param is typed as LP void. What's nice about void is it's very simple to typecast this into pretty much anything else. So what in the world do we need to typecast this into? Well, it's the structure, right? The structure type that we need. So we'll come in front of this and we'll say pargs. Okay, cool. But now we need to take all of that and put parentheses around the whole thing. That way we can go and access the members with arrow notation. All right, so there goes, pops up, file name. Sweet. All right, so save it, build it, and then run it. Okay, so look at that. At the very, very top, we have thread arg C users splat. Hey, how about that? You just pass a pointer to a structure that had a member for a file name. Okay, you could add in other members as well to the structure to have multiple arguments being parsed or whatever. This is my preferred way to mess around with passing an argument to a thread. All right, that's called, or to a function that's called with a thread. All right, there you go, TPZ. That's the answer for you. Yeah, not ARM. Ugh, ARM. All right, cool. So with this parameter, what you could do is instead of using the C:\\/ here, you could optionally go ahead and take this and put it right here to go ahead and say, let's go ahead and process whatever is coming in as the arguments from main, right? If you want to do that. So cool. One of the things that we haven't done is this. We haven't properly freed up some of our resources. So we allocated stuff on memory. We have some handles that we're waiting for, but we haven't properly cleaned up after ourselves. So let's go ahead and do that. All right. So with the heap allocation, one thing that we need to do is it's nice to validate that we actually have a pointer to the chunk. Cool. But we need to free it. We should go ahead and be nice to the system and free that resource as we don't need it anymore. And also, we don't want to leak anything either, right? Don't want to leak handles, don't want to leak resources, anything like that. Cool. So after our wait for single object infinite, once we're done, one of the things we should do is we should close our thread handle. Okay, so cool. We got that. Next thing we should do is we should go ahead and free up that chunk of memory. Now, if you want to be super paranoid, you could do another check against pargs just to make sure it's there. But again, we've already done that. So this is kind of redundant, but already typed it out. So whatever. So now that we called heap alloc, there's a specific function that you have to call to free that. So we'll say heap free. All right, so heap free. And then it's going to say, hey, I need your handle. I need your handle to the heap. So we use the process heap. So we're going to use that again because it has to match. Then the documentation will say there's really one flag that, or two flags that you could use for here. And that's no serialization, heap no serialize. We don't need that, right? So we don't care about that right now. So we just say 0. Now we need a pointer to the actual chunk that needs to be freed. So that's our pargs. Okay, so we free that. Awesome. We just gave that chunk back to the system to go ahead and use it for whatever else it might need. But I like to go and do one step further. At this point in time, let me go ahead and see if I can set up a breakpoint right here and kind of show you this before I make the fix. All right, so I'm breaking a heap free. All right, and then looking at pargs, pargs has a value, right? Awesome. Let's see. Okay, so inside a memory window and just type in pargs and it shows me the value. Sorry, it shows me the memory address of it and the value that it has. So I'm going to free this. Let's step over this. Heap free. Boom. You see that's gone, right? But it's not, it hasn't been overwritten with zeros. It's been overwritten with, looks like some pointers would be my guess. But in any case, we're still pointing to something. Look at that. pargs still has a pointer in it. I don't want that. I'm not cool with that. Okay. So one of the things, and we kind of got lucky that we didn't have more data on the heap here because that still could have been here, right? What we could have done if you're extra paranoid is go ahead and zeroize everything that you put there once you're done with it. Just wipe it all out, override it with all zeros, then call heap free. And then after that, come in and reset your pargs to null. Okay, it is basically just coming back to that local variable and giving it a new value, just nullifying it, right? Or null it out is what some people say too. So let me show you this now. Okay, we'll run this again. Okay, we got our heap. Awesome. And we'll free it. Cool. And we'll go ahead and step over. There we go. Null, right? That's what I want. That's what I like to see. Nothing in memory. Okay, so cool. All right, so that's specific to the heap, right? Go ahead and free that out. That can be for other things that you might have to allocate dynamically as well. I really like to have that implemented in pretty much all of my code. I'll come back in after I free something that I allocated dynamically or whatever. I'll come back and say, you're not pointing there anymore. You're pointing to 0, right? So you null it out. Okay. All right. So we close our thread handle. If you wanted to, you could optionally come back into hthread and null that out as well. There's really no point in doing that unless you're just extra paranoid. Okay. Inside of dir utils, one of the things that we didn't do is close our search handle once we're all done with it. Okay, so you might be wondering, hey, Jonathan, why didn't you use close handle for this one like you did for the thread? Right, you call close handle on it but we have a completely new function now for this. The reason why is because your search handle that gets returned to you by find first file is not a real handle. You can kind of think of it as like a pseudo handle, if you will. But if you call close handle on it, it's gonna be like, I don't know what this is, man. I don't know what kind of handle this is. All right. So we call find close. All right. It's part of the find API family. And this function knows how to treat that specific handle. Okay. So cool. There we go. We took care of some of our leaks that we had, leaking some handles, not properly freeing stuff up on the heap, not nulling out some parameters and some pointers, stuff like that. Because technically, this is like a dangling pointer, right? I talked about pointers way earlier in the series, talked about dangling pointers and stuff like that. So go back to earlier parts if you want to dive into dangling pointer. Cool. So that's all I really have for you for today. We used a thread, in summary, we used a thread to implement a dir walking capability. Inside the dir walk, we played around and did some testing against attributes for each entry, whether it's a directory attribute or not. We looked at creation time, access time, last write time, last modify time, printed those out, full file size, stuff like that. Looked at thread stacks and dynamic allocation on the heap. So we got about a few minutes left, about 4 or 5 minutes left. Open up. Does anybody have any questions about any of this code that we were working on together? Does anybody have any questions outside of this, previous parts of the series, future series? Fire away. Yeah, no problem, TPZ. All right, looks like, what am I doing after this series is over? Well, I would like to do an intro to C++. It probably won't be a 10-part series. But yeah, I think that's kind of what I'm leaning towards. That or WinDbg. Not sure if I'm going to do WinDbg first or C++ just to take a break from programming for a little bit. But yeah, I don't know. We'll see. We'll see if I do a 10-part series for C++. I mean, to be honest, I tried to put these out once a month as best as possible, but I'm swamped as it is. So another 10-part series for me is basically like a year, right? Yeah, 10 months worth. But yeah, in any case. All right. So if nobody else has any questions, I'll hang around in Discord for just a little bit if anybody has any post questions. But we'll go ahead and terminate the Zoom workshop here. And then we'll see you all at a future part 9. All right, y'all. Have a good one.